Okay, so in this video we are looking at how we use the moles equation to work out the number of moles of solution or of a solid. Okay, so we've got two equations that we need to be happy with. The first one is my number of moles is equal to the mass that I have divided by the relative formula mass. In your exams, this one will also be called R. Okay, and the second one is that number of moles is equal to C times V, where C is concentration and V is volume. So if I look at an example, we can use that to calculate the number of moles. Okay, so if we take an example, okay, so we've got a chemical of sodium hydrogen carbonate there, okay, and we can work out how many moles are in that spatula of the sodium hydrogen carbonate. Okay, so I'm going to tell you that in that spatula of sodium hydrogen carbonate we have 1 gram. Okay, that is what I mean by the mass. Okay, and we also need to know that the formula of sodium hydrogen carbonate is NaHCO3. Okay, so we need to use that to work out what my relative formula mass is. Okay, so my mass is the actual amount of substance that I have on my spatula. In this case, that is 1 gram. And my relative formula mass is the mass of each of the elements added together. Okay, so in this example, I have sodium, I have hydrogen, I have carbon, and I have 3 oxygens. Okay, so I can look at my periodic table, and I remember from my periodic table that I get the atomic number and the mass number of each of my elements. Okay, so and I remember that the mass number is the bigger of those numbers. Okay, so the mass number of sodium is 23. The mass number of hydrogen is 1. The mass number of carbon is 12. And the mass number of oxygen is 16. Okay, so I know I've got 1 sodium, I've got 1 hydrogen, I've got 1 carbon, and I've got 3 oxygens, so I need to multiply that oxygen by 3. Okay, and then I need to add each of these together. Okay, so I've got 23 plus 1 is 24, plus 12 is 36. Okay, and those 16 times 3 is 48. So 36 plus 48 is 80. Do that in my head. 84. Okay. So I know the relative formula mass of sodium hydrogen carbonate is 84 grams. Okay, so in my original sample of my hydrogen carbonate, which weighed 1 gram, how many moles do I have? Okay, so I knew that my formula was mass over formula mass. Okay, and that gave me an answer of, I know my mass is 1 gram, and we worked out in the previous section that my formula mass was 84 grams. So I've got 1 over 84 moles. That's my number of moles. Okay, so in that 1 gram sample, I have 1 over 84 moles of sodium hydrogen carbonate. Okay, I can do exactly the same for solutions, except this time I've got an equation where my number of moles is equal to the concentration times by the volume. Okay, the important thing here is my volume is measured in litres. Okay, you'll also see that called decimeters cubed. They mean the same thing. Okay, so if, for example, we have this blue solution, okay, and I know that I have in my blue solution 80 centimeters cubed of solution. Okay, and I also know that that solution has a concentration of 1 mole per decimeter cubed. What that means is in 1 litre I would have 1 mole of solution. Okay, so how many moles of solution would I have in 80 centimeters cubed? So what I need to do is I need to multiply my concentration by my volume. Okay, and then plug my values in. So in my equation I've got concentration times by the volume. Remember, my volume needs to be in litres. Okay, so my first step is I need to convert 80 centimeters cubed into litres by dividing it by 1,000. Okay, and that is equal to 0.08 decimeters cubed. Okay, and we said that was exactly the same as litres. So whenever I'm using a volume, okay, I need to make sure that I am converting it into litres first of all. Okay, so I know that I have a number of moles equal to my concentration times by my volume. I know my concentration is 1. I know my volume is 0.08. So my number of moles is equal to 1 times 0.08, which is the same as 0.08. And it would be exactly the same for if my concentration was higher, my volume was higher. I could use exactly the same equations to work out my number of moles. Okay, in the next part of the video, what we're going to look at is rearranging each of these equations to work out the mass of your solid, or the concentration of your solution, or the volume of your solution. Okay, so I had my number of moles equal to my mass over my molecular mass. I use that one when I'm dealing with solids. Okay, and I've got N equals CV, concentration times volume. I use that when I'm dealing with solutions. Okay, so I can rearrange these equations to work out my mass. So my mass is equal to my number of moles times by mR. Okay, and I can rearrange the second equation to work out the concentration. So the concentration would be my number of moles divided by volume. I can also use it to work out my volume, which would be the number of moles divided by the concentration. Okay, so we can use these equations to work out the number of moles of a solid, the number of moles of a solution. If I know the number of moles of a solution, the concentration of that solution, or the volume of that solution, and if I know the number of moles of a solid, to work out the mass of that solid. Okay, so in the next video what we're going to look at is combining these different equations together and working out in a chemical reaction how much of each chemical we actually need to add together.